You guys, chapter 11, you made it. It's the last chapter in algebra. We did go ahead and went over this in class yesterday, but we're just remember that the dividend is on the inside, the divisor is knocking on the door, and the quotient's always the answer to a division problem. You're going to see lots of different ways to see these division problems written, and so I just wanted to make that available to you. And here we go. We are going to talk about how to divide a polynomial by a monomial. This, I think, is the easiest way of division. We're basically going to split this 2x up into each one. Okay, so I'm going to rewrite it, and I'm going to do 4x to the third over 2x. I'm going to keep that addition sign. It's going to be 8x squared over 2x. I'm going to keep that addition sign, and it's going to be 10x over 2x. Now what I can do is I can go through and reduce everything. Well, 4 and 2, that goes down to 2 over 1. X to the third and x, remember if I have 3 on top and 1 on the bottom, 1 cancels and I'm left with 2. And I don't really need that 1 on the bottom there. 8 and 2, that becomes 4 over 1. Again, don't need the 1. And I get 2 of the x's, so one of them cancels. And finally, 10 and 2, that goes down to just 5 over 1, and then my x's cancel. So this actually becomes my final answer. Now, I know that it's just simplified as much as it can. It doesn't really mean it's an answer for us, but we're reducing it. Okay. On the next one, we're going to do the same thing, and we're just splitting everything up. Now, notice on the bottom there is a negative 2x. I'm going to keep that plus, and we're going to do a couple of different things when we solve, and you'll see here just a second. Okay, so again, we're just reducing. So 10 divided by a negative 2 gives me a negative 5. 3 minus 2 is just 1x. 4 divided by a negative 2, that gives me a negative 2. Notice how my sign flipped here because I had that negative. And then 2 minus 1 is just 1. I've got 12 divided by a negative 2. That one actually gives me a negative 6. Now this is tricky because I don't have an x here. So since there's an x on the bottom, it's actually going to stay on the bottom. Okay, and you're going to see some division problems that look like that in a second. So that is with a monomial. Another way we can do a monomial is just like a division problem. We have practiced these and gone over how to divide, and so we're going to go through them. So I look at 2 and 4. Well, how many times does 2 go into 4? That would be twice. And how many, if I subtract my x's, okay, that's going to be 2 x's. So I am going to multiply these to my quotient with my divisor. I'm going to multiply them together, and I'm going to get 4x to the third. And then I'm going to subtract, just like I would a normal division problem. I'm going to bring it down, bring it down, bring it down, everything I have here. And I'm going to say, how many times does 2 go into 8? Well, that would be, remember, keep your plus, 4 times. 4 times 2 is 8. And then how many x's do I have? Well, I'm going to have 1 plus 1, which is going to give me 2, and I need to subtract and bring it down. That cancels, so I'm left just with 10x. I have 2x into 10x. Well, 2 goes into 10. That would be plus 5 times. So 5 times 2 would be 10, and then there's just 1x there, so that would end up being 0. Okay, let's do that again. So 4 into 12, that's going to be 3, and I'm going to subtract my x's, so I'm going to get x to the third. So then I'm going to multiply back out. So 4 times 3 is 12, and I'm going to get x to the fourth, subtract, and bring everything down. Okay, so now that I have a negative 16, 4 goes into a negative 16, that would be a negative 4, and then subtract my x's, so that would be squared. So a negative 4 times 4 is a negative 16, and that would be x to the third. Now remember, when we subtract, we actually tick here. So those cancel and leaves me with just 20x squared. Okay, 4 into 20, that would be a positive 5, and 1x would be a positive 20x squared. Again, cancels and gives me 0. That's what I like to see. All right, next term, a negative 2 into 10. Well, that's going to be a negative 5. I subtract my x's, and I get 3. So a negative 5 times 2 would be, a negative 2 would be a 10, and that would be x to the fourth. We subtract those. I bring down my negative 8x to the third. So negative 2x goes into negative 8x to the third. That would be plus 4x squared. So a negative 2 times 4 is a negative 8x to the third. Perfect, because if I subtract, I tick those and cancel. And I bring down my 4x squared. A negative 2 goes into 4. That would be a negative 2 times. And I'm going to need 1x up there because that would then give me a positive 4x squared, which if I subtract does indeed cancel. Perfect. So those are two methods. Sometimes I have a remainder. And we always, with long division, we want to keep our remainders as a fraction. Okay, it's going to be the remainder over your divisor, or what's knocking on the door. Okay, so 2x into 4x, that's going to give me 2x squared. I multiply those back out, 4x to the third. Then I'm going to go down and drop my negative 14x squared. It's really important to rewrite these guys so you don't lose track. So 2 goes into a negative 14, that would be a negative 7x. That would be a negative 14x squared. Remember those ticks, so they cancel. I bring down my 3, my positive 3. Okay, so here's the case where 2x does not go into 3, my positive 3. So what I'm going to do is I'm just going to add 3 over 2x. It's going to be like a fraction, okay? And that's going to be my answer. On the next one, x goes in x to the fifth. That would be x to the fourth times x gives me x to the fifth. I subtract, those cancel. 2x squared comes down. X goes into 2x squared. That would be plus 2x. Plus 2x, that would be 2x squared. I subtract those, they cancel, and my 5 comes down. Now, x doesn't go into 5, but it is a positive 5, so I'm going to put plus 5 over my denominator, which is x. All right, moving on. Long division with polynomials requires putting them in order. Place terms in descending order, making constants last, keeping the signs immediately before them when terms are moving around. So what you want to look for is the highest exponent. So I'm going to do a negative x to the third plus x squared. And then I'm going to do plus 5x plus 4. That's all we're doing here is we're just rearranging them and putting them in order. On the next one, I get 3x squared minus 9x plus 1. On the next one, I have a negative 2x squared plus 5x plus 7. And you get the idea. Last one is going to be a negative 2x plus 4. They have to go in order. Now, however, with division, sometimes we need to insert missing terms with a 0 coefficient. 0 terms serve as a placeholder, and which we need for long division. So you'll see it goes 3, 2, 1, 0. 5, 4, 3, 2, 1, 0. So we're going to rewrite these next ones. So I'm going to go 4x to the fourth. I don't have a third, so I'm just going to do plus 0x to the third plus x squared plus 5x, and then it's going to be minus 2. On the next one, I'm going to do 4x squared plus 0x plus 10, and that would be x to the 0. Okay, and on the last one, it's going to be we want a different color. 4x to the fourth. I don't have a third, so it's plus 0x to the third minus 5x squared. I don't have an x, so we're going to have another one here, and minus 3. Now that's going to be important as we do division because you're going to see that it's going to get a little more complicated because now we've got two terms that we're working with. Remember, the first term is the first one to the party. They get to go inside first. That is the dividend. Okay, they get to go in. The divisor is knocking on the door. Okay, so here's what I need to look for. I'm looking for my x and my negative 1. So x goes into x squared, so that's just going to be x. So x times x is x squared, but I also have to take it times that negative 1. So x times a negative 1 is a negative 1x. Now this is why I need my placeholder, because now I'm going to subtract. Now when I subtract these front ones, they cancel, but when I subtract the back, it actually ticks. So it's 2 minus a negative 1, which would be plus, which is actually going to be plus 3x minus 3. Okay, we're done with that 0. Okay, so now x goes into 3x, whoops. X goes into 3x, so that's going to be plus 3. So 3 times x is 3x, and 3 times a negative 1 is negative 3. That's exactly what we want to see, and those are going to cancel and give me 0. This is my answer. Now, if I FOILed those out, what? We go all the way back to FOILing things out. George, FOIL, whatever you want, and you can get back to the original answer, the original polynomial. Amazing! Okay, so I've got x squared plus x minus 6 is on the inside. I've got x plus 3 on the outside. So x into x squared, that's just an x. That gives me x squared, and then that gives me plus 3x. Now remember, I'm subtracting everything, so those two cancel. I have x minus 3x, which is a negative 2x minus 6. So x into a negative 2x is negative 2. So negative 2 times x is a negative 2x. And then I'm going to do minus 6. Look at that. That's exactly what we want to see because we tick, tick, and it goes away. And that's my answer. All right. Next problem. This is already set up for us. So x into 8x. That's going to give me 8x. 8x times x is 8x squared. And then I have to do 8x times a negative 1, which is a negative 8x. I'm going to subtract. These are going to cancel. This is going to tick, tick to give me plus, and I'm going to have a 10x minus 3. X into 10x, that's going to be plus 10. So that would be 10x plus 10. Now, I'm going to cancel these out, so that's going to subtract. This is going to subtract, and it's actually going to give me a negative 13. That is going to be my remainder. I'm going to have my negative 13, and remember what we did before, over x minus 1. So that's a little complicated. That's super intense. That's going to be Algebra 2 stuff that you're going to get into, but just so you can get the answer is going to be awesome. So x into x squared is just x. That would be x squared plus 3x. Remember, we're going to subtract, so those cancel, and then that's going to be a negative 3, which gives me negative 1x minus 6. X into negative 1 is going to be a negative 1. Negative 1x, that's negative 1x. That's going to be minus 3. Now remember, I subtract, which makes up positive, positive, and I'm going to get a negative 3 left. Again, my remainder is negative 3 over x plus 3. And we cannot reduce that at all because it's an addition term. All right, last page here. And I might be running out of time, so bear with me. Now notice that this is backwards. We do actually need to rearrange that. So I need to do x plus 3 on the outside first. On the inside, I need to do 3x squared minus 4x minus 21. Notice I don't need any placeholders here yet, but I will next. So x into 3x squared is 3x. That's going to give me 3x squared. That's going to give me plus 9x. I'm going to subtract. That means that subtracts. That means that's negative 13x minus 21. X into negative 13x, that's a negative 13. So a negative 13x. And a negative 13 times 3 is going to be a negative 39. So when I cancel that, it's going to give me a positive 18. Once I have my positive 18, that becomes my remainder, so x plus 3. Okay, there's my answer. And the last one, again, we're going to rearrange, so I'm going to do x plus 6 on the outside. On the inside, okay, this is going to take a little longer. 4x to the third plus, it's going to be 0x squared plus 9x plus 5. So there's 4 terms on this one. I've got a minute left. Can we do this? Okay. So 4x squared is going to go first. That's going to be 4x to the third plus it's going to be 24x squared. I'm going to subtract. These cancel. This gives me a negative 24x squared plus 9x. X into negative 24 is going to be negative 24x. That's going to be a negative 24x squared, and then it's going to be, oh, this is a big number. It's going to be a negative 144x. Okay, so if I subtract these, that's a tick, tick. That means that becomes, I'm going to move it over, 153x plus 5. So that's going to be plus a 153, and so 153x plus, okay, so that's going to be 9/18, and I'm going to have to subtract an